Hey everyone, and welcome to This Explainer. Have you ever actually paused for a second to think about the sheer scale and the frankly mind-blowing speed of the hardware it takes to load just a single web page? Today, we're pulling back the curtain on connectivity. We're going to explore exactly how your home network interfaces with the vast, sprawling internet. It's this incredibly complex sequence of events, like a literal physical relay race that connects your fingertips to the rest of the globe. And in This Explainer, we're going to break down that hidden physical reality. So think about this. How does a simple tap on your screen reach servers thousands of miles away in a literal fraction of a second? I mean, it feels totally instantaneous, right? You click a thumbnail and boom, a high-definition video starts playing before you can even blink. But behind that split-second action is a meticulously engineered physical reality. Let's actually track the journey of your data request as it leaves your living room, navigates through your walls, and travels out across the world. We're going to follow a single data request sequentially through 5 key checkpoints. First, the starting point at your device and Wi-Fi. Second, the home router. Third, the ONT device. Fourth, the national telecom network. And finally, the global internet. Okay, let's dive into this. Step 1, the starting point, your device and Wi-Fi. Picture this. You're just relaxing on the couch, right? And you decide to stream a video on your smartphone, your smart TV, or maybe you're browsing on your PC. The exact moment you press play, your device generates a request that flies right across the room via short-range radio waves. That's our Wi-Fi acting as the wireless bridge to your home's physical network. So instead of being tethered to the wall with a physical copper cable, these invisible radio frequencies are just effortlessly carrying your data straight through the air. Which brings us to step 2, the traffic controller, your home router. So, those radio frequencies flying through your living room, they need a destination to actually be processed. They hit the very first physical box in your house, which is the router, often referred to as the CPE. Now, this piece of hardware is basically the master traffic controller of your local network. Imagine a busy household. Someone streaming a 4K movie in the living room, maybe someone upstairs is playing an intense online multiplayer game, and meanwhile, your smart fridge in the kitchen is just quietly running background updates. The router assigns local IP addresses to every single one of those connected gadgets and meticulously organizes all the outbound data. This prevents data collisions and manages bandwidth, keeping the digital traffic of your entire household perfectly organized. Moving right along to step 3, the optical translator, the ONT device. All right, with the data neatly organized, it finally leaves the router through a short physical cable and heads toward an absolutely critical gateway that's usually mounted right on your wall. We're talking about the ONT, or Optical Network Terminal. Basically, this is your fiber optic modem. Its entire vital job in this whole process is to translate the electrical signals coming from your router into rapid pulses of light. Now, what's really interesting here is thinking of the ONT as the diplomatic translator of your network. Think about it. The inside of your house speaks one language, but the street outside speaks a completely different one. The ONT stands right at the border of your home. It takes that relatively slow, heavy electrical language of your indoor router cables, and it instantaneously translates it into the lightning-fast optical language of the outside world. It seamlessly negotiates the physical boundary between your private living space and the massive public infrastructure out there. Just to put that into perspective, inside your house, the environment is entirely based on electricity, right? We've got copper cables, routers, standard electronic signals. But the outside world, that massive telecom network waiting just beyond your wall, operates entirely on light and laser pulses, shooting through ultra-thin glass threads called fiber optics. The ONT is exactly where that beautiful physical change happens. Your simple click to play a video literally ceases to be an electrical charge and becomes this instantaneous flash of laser light entering a microscopic glass tube. Crazy, right? And that brings us to step 4, the highway, or telecom network. Okay, once that data becomes light, it hits the fast lane. I mean, we are talking about a massive, underground highway system of subterranean cables and huge switching centers that actively bridge entire cities. Those tiny flashes of light carrying your video request are now literally zooming beneath streets, under rivers, and across the country. They are traveling immense, mind-boggling distances across the national telecom network without losing a single ounce of momentum. It's a total engineering marvel right beneath our feet. Finally, step 5, the final destination, the global internet. Our light pulse arrives at the massive global servers. We're talking about colossal data centers for companies like Google, Netflix, or really whichever site you happen to be visiting. The data request is instantly processed by these servers, fulfilling your exact action. And here is the truly astonishing part. The server immediately sends the actual video file or web page bouncing back along that exact same path. From the server, back down the underground fiber highway at the speed of light, back into your home's ONT where it transforms back into electricity, into your router, out through the Wi-Fi radio waves, and straight onto your screen. It happens so incredibly fast you barely even perceive a delay. No way, right? Let's move to a quick visual summary and see how this all builds together. Step 1 initiates at your device, creating those invisible Wi-Fi waves. Step 2 hits the home router, organizing your traffic. Step 3 enters the ONT, translating the electrical signal brilliantly into light. Step 4 speeds down the massive telecom network. And Step 5 finally hits the global internet servers. It is just an amazing, perfectly orchestrated chain of events. So if you look at the breakdown, every single second you are online, a flawless sequence of translations is happening, from radio waves to electricity to light. Your device to the router relies on radio waves. The router to the ONT uses electricity flowing through a physical cable. And the ONT to the telecom network relies on fiber optics using lasers. It seamlessly and continuously converts these mediums over and over again. And the best part? It does all this to keep you connected to the world without you ever having to lift a finger. You know, it's so easy to take this infrastructure for granted when it works so effortlessly day in and day out. But I want to leave you with a final thought here. The very next time you sit down to stream a video, load up a web page, or even just send a quick message, take a brief moment and ask yourself, how many miles of glass and light did that simple click just travel? The physical reality powering our digital lives is honestly nothing short of breathtaking. Thank you so much for joining me on this explainer today. I really hope you found this whole journey as fascinating as I do. Keep wondering, keep learning, and I'll see you next time.